Hello everyone, welcome back to my channel. My name is Sandeep and this is part 1 of the top 50 Power BI DAX interview questions and answers series. If you are preparing for a Power BI interview, make sure to watch this video till the end. I am confident it will help you answer most DAX related interview questions. This video will also be really helpful for solving DAX related problems in your Power BI projects. In this video, I will explain each and every DAX functions, definitions, use case, syntax and DAX code in a very simple way. So stay with me till the end. If you find this video helpful, don't forget to like, share, subscribe and leave a comment below. It really helps me make more videos like this. Now let's start the video. First DAX function is sum, one of the most important DAX function. I am sure if you have worked in Power BI, you have definitely used this in your reports. Let's understand the definition first. Adds all values in a single column. So let's suppose you have sales column and you want to calculate total sales, then you can use sum DAX function. And here you can see the use case. Calculate the total sales amount from a column. It can be anything, any numeric value such as profit, quantity, price, sales and many more. And here you can see the syntax, sum and column name. It supports only single parameter which is column name. And this is the DAX code for the sum function. Total sales equal to sum of sales. So here sales is dataset name and sales amount is column name. So it will return the total sales from sales amount column. This is very simple DAX function, easy to use and very important from an interview point of view. Second DAX function is SumX. See the definition first. Iterates over a table and sums the result of an expression. In simple word, it works by going row by row through a table, calculating an expression for each row and then aggregating those results. See the use case. Calculate row wise total for quantity multiplied by price. This is the syntax SumX and it supports two parameter table and expression. This is the DAX code example for the SumX. Total line sales equal to SumX. In first parameter we passed sales which is table name, and in the second parameter we multiplied quantity by unit price. And here you can see the data set where we have three columns: product, quantity and unit price. So here SumX DAX function first check the calculation for first row. It will pick up the quantity 8 for the eraser product and then multiplied by unit price 1.50, and after that it will return the total line sales result 12. Then it will go to the second row where we have product marker. It will pick up the quantity 5, then multiplied by unit price 8, and then it will return the result 40. In same way it will perform the calculation row wise row and will return the result. Third DAX function is count rows. As name suggests, count rows. Returns the number of rows in a table. Here you can see the use case. Count the number of rows in the sales table. This is the syntax, count rows. It supports only single parameter which is table name. And this is the DAX code example for the count rows. Order count equal to count rows, and this is the sales table name sales. And here you can see the result. It returns 7. Means in the sales table we have only 7 record. This DAX code is very simple and easy to use. Fourth DAX function is distinct count. It counts the unique values in a column. What can be the use case? Count the number of unique customers. This is the syntax, distinct count, and it supports only single parameter which is column name. This is the DAX code example for the distinct count. Unique customers equal to distinct count and here we pass the customer ID column name from the orders dataset. And this is the dataset where we have customer ID, product ID and sales. And here you can see the same customer ID is repeating multiple times because one customer can order multiple products. But here we want to count the unique customer ID. So that's the reason we use distinct count, and here we pass the customer ID and it returns 17,000 unique customers. So again, this is very important DAX function for the data analysis. Fifth DAX function is calculate. This is very important DAX function in the Power BI. So understand this DAX function very carefully. So let's start from the definition. Evaluates an expression in a modified filter context. In simple word, it helps you do calculations like sum, count, average and many more, but with custom filters. This is a use case. Apply a specific filter like country equal to United States to a measure. This is a syntax, calculate, expression, and it supports multiple filters condition. This is the DAX code example for the calculate. Sales USA equal to calculate sum of sales, comma, country equal to United States. So it will return the total sales only for the United States. Here you can see that 2.30 million. Now understand why we used calculate DAX function here. If you remember when I explained you some DAX function, so here some DAX function only support single parameter which is column name. Here you cannot pass any filter condition. But here we have situation like that. We want to see the sales only for the United States country. So that's the reason we used calculate DAX function here, and it allows us to pass the custom filters to a measure. So here we have expression or measure sum of sales, and here we pass the filter condition, or we can say the custom filter, which is country equal to United States. So I hope you understand why calculate DAX function is important. Sixth DAX function is filter. Again, this DAX function is very important. It returns a table with rows that meet a condition. This is a use case. Return sales only for transactions greater than 1000. This is a syntax, filter. It supports two parameter table and filter condition. This is the DAX code example for the filter. Sales greater than 1000. This is the measure name equal to calculate sum of sales, comma, filter, and here in the first parameter we pass the table name orders, comma, in the second parameter we pass the condition sales greater than 1000. So it will return the total sales only for the records where sales greater than 1000, and here you can see the output 4.80 million. Now understand how filter DAX function works. So filter DAX function only supports two parameter. So in the first parameter we pass the table name orders, and in the second parameter we pass the condition. So first it will filter only rows where sales is greater than 1000 and will load the data into orders table, and then we use sum of sales. So in orders table we have only sales for the records where sales is greater than 1000, and then it will return the total sales. So I hope you understand how filter DAX function works. Seventh DAX code is values. It returns a list of unique values from a column. What can be the use case? Give me all the different values from this column. Here this column means it can be anything. You can pass any column name here. So for an example, here I passed product column name. This is the syntax, values, and it support only single parameter. Either you can pass the table name or column name. This is the DAX code example. List of products equal to values, product column name. In the screenshot you can see that here I created one table to use in DAX expression. When you will go to the modeling tab, you will see the new table option. So you can create a new table using DAX expression. So here list of products is a table name and then equal to values product column name. So it will return the table with single column name which is product, and here you can see that unique products name. So this is the use case of values DAX function. Eighth DAX code is has one value. This is a very important DAX function. You can use this DAX function in multiple scenarios. First, understand the definition. Check if a column has only one distinct value in the current filter context or not. If there is only one value, it will return true, else false. What can be the use case? Check if exactly one category is selected in a visual or not. This is a syntax, has one value and it supports only single parameter which is column name. This is the DAX code for how you can use has one value in this use case. So here we used if DAX function. It supports three parameter logical test, true and false. So in the logical test we passed as one value in the category column, and in this screenshot you can see here right now we only select single category which is furniture. So here as one value DAX function checks whether the category column has only one value selected or not. So here we only select one value, so it will return true, and in the true condition we used values DAX function in the category column, and we know very well values DAX function returns a table with single column name, and here column name is category. So right now we only select furniture, so here value DAX function will return only furniture value in the column, and that's the reason here you can see the only furniture as in output. Now check the same for multiple values. So in second screenshot you can see here we selected multiple categories which are furnitures and office supplies. So here, so again as one value DAX function checks whether the category column has only one value selected or not, but this time we selected multiple values, so it will go to the false condition, and in the false condition we have default message multiple. So that's the reason for the multiple values it is showing multiple. So I hope you understand how you can use as one value. Ninth DAX function is selected value. This is a very important DAX function. I have personally used it in many of my reports to display the selected value as in text in the visual title. It returns the value when only one value is selected, otherwise blank or default. Use case, display selected value from slicer or default text if none. This is a syntax, selected value. It supports two parameter, column name and alternate result. This is a DAX code example for the selected value. Selected reason equal to selected value, reason column name, comma, alternate value, all reasons. So whatever value you will select from the reason slicer, so it will return that value. So here you can see in the slicer, I only select Canada region. So in the card visual you can see the output Canada. If I will select multiple values from the region slicer, so it will return only default message which is all regions. This is very useful DAX code if you want to show the single selected values in any visual or for the visual title. 10th DAX function is switch. This is very simple or common DAX function but most usable DAX function in the Power BI. It checks a value and returns different results depending on what that value is. What can be the use case? Categorize sales into high, medium or low based on value. This is the syntax, switch, expression, then pass the value and value result, then again pass the value and result. In same way you can pass the multiple values and result. And this is the DAX code example for the switch function. Sales category is the measure name equal to switch, then we pass the true DAX function. So here true DAX function allows you to check logical conditions one by one in order. and then we pass the total sales measure name. So here total sales measure equal to sum of sales. So if you already created the measure, so here you can pass the measure name like this, and else you can directly write the code sum of sales. So total sales greater than 50,000, then show the value high. If total sales greater than 10,000, show the value medium, else low. So here in the screenshot you can see the output of sales category DAX measure. So here for the Canada you can see the total sales is 66,000 something. So here we have condition if total sales greater than 50,000, show the high. So that's the reason for the Canada sales it is showing high. And here for the Central Asia sales is 19,000 something and is showing medium. So here you can check the condition if total sales greater than 10,000, show the medium. So that's the reason for the Central Asia it is showing medium. So this is the use case for the switch DAX function. 11th DAX function is divide. You know very well what is divide. It safely performs division, avoiding divided by zero errors. What can be the use case? Calculate profit margin and handle divide by zero errors. This is the syntax divide. It supports three parameters: numerator, denominator, and alternate result. This is the DAX code example for the divide. Profit margin is the measure name equal to divide sum of profit, comma sum of sales, comma 0. If any error occurs during the division, so it will return the 0. So with the help of divide DAX function, you can divide the two values and also you can handle the divided by 0 errors. So in the screenshot you can see the total profit, total sales and profit margin measures result. 12th DAX function is if. This is one of the most common and widely used DAX functions. I am 100% sure you have used it at some point, whether in SQL, Excel or somewhere else. It evaluates a condition and returns one value if true, another if false. What can be the use case? Add logic based conditional columns. Means create one calculate columns based on some conditions. This is a syntax if it supports three parameters: logical test, value if true and value if false. This is a DAX code example for if. Create one calculate column in your existing data set and write this DAX code. So here flag is the column name equal to if sales is greater than 200, so show the values high, else low. In the screenshot you can see the output of flag column. So here we have sales 414.24, so it is showing high because in our condition we define if sales is greater than 200, show the high. And here we have sales less than 200, it is 177.66, so for this sale it is showing low because if sales is not greater than 200, show the value low. So this is a very simple DAX code but most usable in the Power BI. 13th DAX function is RankX. As name suggests, you can use this DAX function to provide the rank to your data. Now see the definition. Ranks values over a table based on an expression. Provide the ranks to the products based on the sales values. This is the syntax. RankX, then table name, expression, value, order and ties. These are the parameters for the RankX DAX function. Here few parameters are optional, so it totally up to you. You want to pass the value for them or not, otherwise leave it blank. And this is the DAX code example for the RankX. So here product rank is the measure name equal to RankX. First parameter is table. So here all DAX function will return the table with single column name which is product. Then we have expression. So in expression, so here we used calculate DAX function with total sales measure. So here total sales measure equal to sum of sales, and after that we didn't pass anything on value parameter, so we leave it as blank. Here you can see that. And then in the orders parameter, we pass descending order because we want to see the rank as in descending order. And in the last parameter, we didn't pass anything. So here you can see the rank for the product based on sales value as in descending order. So for a product A, we have very less sale 100. So that's the reason. For the product A, product rank is 4. Then we have B. For the B, we have 150 sales. So for the B, we have rank is 3. And here for the product D, sales is very high 300. So that's the reason for the product D, product rank is 1. 14th DAX function is related table. It returns a table of related rows from another table. What can be the use case? Count all related rows. Example, orders for each customer. This is a syntax related table. It supports only single parameter, which is table name. And this is a DAX code example for the related table. Now understand the prerequisite for the related table. How you will use related table DAX function. Here you can see that we have two tables, customer table and sales table. In the customer table, we have two columns, customer ID and customer name. This is a dimension table. Second, we have fact table, which is sales. Here we have multiple columns such as customer ID, order ID, product and sales. And after that, we set up the relationship between both tables based on customer ID column. Now requirement is we want to see the all customer orders count in the dimension table against the customer ID. So for an example, in the dimension table, which is customer table, here we have customer ID C001 and we want to see the customer ID C001 all orders count here. So if you notice here in the sales table, we have 3 orders for the customer ID C001. So we want order count for the customer ID C01 3 here. So this is our requirement. So with the help of related table, we can easily achieve this. And in the dimension table, we will create one calculate column, related orders, and then we will write this DAX code, count rows, related tables, and we will simple pass the sales table name here. So now you can see the output in the dimension table. This is the related orders, calculate column. For the customer ID C001, here you can see the order count 3. So in the fact table, you can clearly see the for the customer ID C001, we have 3 count. Same for customer ID C002, we have 2 order count. In the fact table, you can see here. And same for customer ID C04, we have only 1 count, which is this one in the fact table C004. I hope you understand in which scenario you can use the related table and why related table is useful. 15th DAX function is related, and this is a very important DAX function. Most of the time you will use this DAX function to retrieve the data from the dimension table into fact table. Now see the definition, fetches a related value from another table many to 1. What can be the use case? Retrieve related values. Example, customer name from a dimension table into a fact table. Now look into the data set. This is the same data set which I showed you in the related table example. So we have two tables. One is customer and customer table is dimension table and sales table is fact table. In the dimension table, we have two columns, customer ID and customer name. In the fact table, we have customer ID, order ID, product and sales. And based on customer ID column, I created relationship between customer and sales table. And here you can see the relationship is one to many. In the dimension table, we have unique values and in the sales table, we have multiple values. So that's the reason continuity type is one to many. Now our requirement is we want to retrieve the customer name values from the dimension table into fact table. So for that I created one calculate column in the fact table which is sales table, and this is a calculate column name, customer name equal to related, and pass the customer name column from the customer table. So what related DAX function will does, it will retrieve the customer name from the customer dimension table into fact table. So here you can see the output. This is a fact table and Here you can see the customer name. This is a use case of related DAX function, and I am 100% sure you will frequently use this DAX code in your report. In the 16th number, we will calculate cumulative total or running total sales. This is a very important DAX interview question, so understand this very carefully. First, see the definition. Calculates the running total over time. And what can be the use case? Track running total of sales over time. And this is the DAX for example to calculate the cumulative sales. So here cumulative sales is the measure name equal to calculate, and then we pass the total sales measure name. Here total sales is equal to sum of sales. If you don't have total sales measure, so you can write sum of sales here. Then we use filter DAX function, and we know very well filter DAX function support two parameters. In first parameter we have to pass table name, but here we used all DAX function, and all DAX function also return a table. So here we used order date column, so it will return a table with order date column, and also all DAX function remove the filters, so it will return all date from the order date column. And then in the filter condition we use this condition order date less than equal to max order date, so it will cumulative the sales until it will reach the max date. And here you can see the result of cumulative sales. We have order date, sales and cumulative sales result. For the 4th of January, sales is 16.45. Cumulative sales is showing the same sales because before 4th of January, we don't have any sales. So that's the reason it is showing same sale. For the 5th of January, we have 288.06 sale, and you can see the cumulative sales result 304.51, which is the total sales from 4th of January to 5th of January. So 16.45 plus 288.06 equal to 304.51. For the 8th of January, we have 87.16 sale. Cumulative sales result is 391.67, which is total sales from 4th of January to 8th of January. 16.45 plus 288.06 plus 87.16 equal to 391.67. So in same way you can cross check the result for the cumulative sales. And if you notice here in the DAX code I used order date column. So instead of this you can also use the calendar date column. So for that you have to create one calendar table and set up the relationship between calendar table date column to order date column from the orders data set, and in the DAX code or in the visual use the calendar date column instead of order date. Reason behind calendar table contains date in continuous sequence, and if you notice here in our original orders data set few dates are missing. So for an example 6 and 7 January dates are missing, and if you want to understand the how cumulative DAX works, so for that dates should be in the continuous sequence, but still you are able to understand how DAX is working. But for the best practice always use calendar date. In my couple of previous video I explained in detail level how to create calendar table. So for that you can refer my calendar versus calendar auto DAX video, and also you can refer learn all types of time and intelligent DAX functions. So in both videos I explain in detail level how to create calendar table and why calendar table is required. 17th DAX function is same period last year. See the definition, returns the same date range from the previous year. What can be the use case? Compare this year's sales with the same period last year. See the syntax, same period last year, and it support only single parameter which is dates. And this is the DAX code for the same period last year. So here same period last year is the measure name equal to calculate sum of sales which is coming from orders data set, comma, same period last year calendar date column. So here we created separate calendar table and we established the relationship between orders data set order date column to calendar table calendar date column. And in the visuals and in DAX code we used calendar date column. Now understand the result of same period last year. So here you can see we have two matrix visual, and in the right hand side we have 2013 year data. So for the 2013, we will understand the same period last year result. So as the name suggests, same period last year. So for the year 2013, it will show you the result of 2012 year data. So for the year 2013, 1st of January, actual sales is 10,006.66, which you can see here. But if you notice here, the result of same period last year, it is showing 808.56, which is same period last year sale, year 2012, 1st January sale, 808.56. And if you see here, 2013, 2nd January actual sales is 3,453.30. And if you look into the same period last year result, it is showing 314.22, which is year 2012 2nd January sale. So see here. In same way, if you look into the sales for the 2013 January 15th sale, actual sales is 8,370.40, and same period last year sales is 2,279.53, which is same period last year 2012 January 15th sales, you can see here. So it will show you the sales for the same period last year. So for the year 2013 January, it will show you the sales for the 2012 January, and for the year of 2014 January, it will show you the sales for the 2013 January. So I hope you understand how same period last year works. 18th DAX function is parallel period. See the definition, shifts a time period forward or backward in time. Understand the use case, fetch values from the same period in a previous year, quarter or month. See the syntax, parallel period. It supports three parameters: dates, number of intervals and interval name. Interval can be year, quarter or month. See the DAX code example for the parallel period. Parallel period is a measure name equal to calculate sum of sales, comma parallel period. In the first parameter we pass the calendar date column name. In the second parameter we passed -1 interval, and in the third parameter we pass the interval name quarter. Now understand the parallel period DAX result. So here we have one matrix visual, and in this matrix visual we used calendar date column name. Here you can see here. Then we use sales column, which is coming from orders data set, and this is the result of parallel period DAX function. So in the interval number and interval name we pass the -1 and quarter. So it will show you the result for the previous quarter against current quarter. So for the quarter 1, here you can see the result is blank. Reason behind, because before 2012 quarter 1 we don't have any sales. So that's the reason for the entire quarter 1 2012 it is showing the blank result. For the quarter 2, previous quarter would be quarter 1. So if you notice here, for the quarter 2 April to June, it is showing the same sales, which is the sales summation for the quarter 1. So here you can see the for the quarter 2, it is showing 3,38,362.81 for the entire quarter 2 April to June, which is the total sales for the quarter 1. So if you notice here 3,38,362.81. For the quarter 3, previous quarter would be quarter 2, and quarter 2 sales is 4,80,132.84. So for the entire quarter 3, it will show you the same sales, 4,80,132.84. In same way, you can change the interval number and interval name, and accordingly you can cross check the result for the parallel period. So I hope you understand how parallel period DAX function works. 19th DAX function is date add. See the definition, shifts a date column by a specified number of intervals. What can be the use case? Shift current period sales by -1 month for month over month comparison. See the syntax, date add. It supports three parameters: dates, number of intervals and interval name. So here interval can be year, quarter, month or day. See the text code example for the date add. So here date at is the measure name equal to calculate sum of sales, comma date at, and it supports three parameters. In first parameters we pass the calendar date column name. In the interval number we pass the -1, and in the interval name we pass the month. Now understand the result of date at DAX function. So here you can see we have two matrix visuals screenshot, and in both matrix visual we have year, sum of sales, and date at result. In the right side matrix visual we have February 2012 data, and in the left side matrix visual we have January 2012 data. So we will understand the date at result for the February 2012. And if you notice here, result of date at DAX function for the 1st of February 2012, sales is 808.56, which is coming from previous month January 1st 2012 sales 808.56. In same way, you can compare the date at result for the February month 2012 with previous month 2012 January. And if you look into the date at result for the February month, whole sales is 98,898.49. You can see here, which is the sales for the previous month January 2012, because in the DAX code we define interval -1 and interval name is month, and here current month is February. So for the February month it will subtract 1 month from the current month and then it will return the result. In same way you can modify the interval number and interval and cross check the result for the date at. 20th DAX function is dates between. As name suggests, dates between. It returns dates between two specified dates. See the use case, calculate sales within a specific custom date range. See the syntax, dates between. It supports three parameters, dates, start date, and end date. See the DAX code example for the dates between. Here sales underscore is the measure name equal to calculate sum of sales, comma dates between. In the first parameter we pass the calendar date column name. In the second parameter, which is start date, so for that we are taking min date from the calendar date column, and for the end date we are taking max date from the calendar date column. Now understand the how dates between will work. If you see here in the date slicer, we select the year 2013, and based on that in the matrix visual you can see the year 2013 sales is 26,77,438.69, which is exactly matching with our dates between card visual result 26,77,438.69. So based on our year selection, dates between will consider the min and max date. So it will take min date from the year 2013 and max date from the year 2013, and based on that it will generate the date range, and then it will calculate the total sales between that range. So I hope you understand how dates between works. That's all for this video. This is part 1 of the top 50 Power BI DAX interview questions and answers series. If you like the video, please like, share, comment for part 2 and subscribe to the channel. Thank you and see you in part 2.